So thanks everyone for joining today. I'm excited to be here presenting. I left my conference name tag here for you, so you can reach me at Ken Owens 12 on Git, or Twitter, or LinkedIn. A little bit about my background and the things I enjoy doing. Today, I kind of want to bring kind of pour together all the different discussion points we've heard so far today. Talking a little about the problem statement that we've been trying to solve at Mastercard, some of the solution that we kind of have come up with, and then give you a demo of the actual solution that we came up with. So when I think about the problem, I think it kind of starts with the direction that the industry is heading with cloud native, and trying to build like run scalable applications in a modern dynamic environment is not an easy thing to do in a large enterprise. As you talk about like loosely coupled systems, most of reliability and availability engineering have you tightly couple your systems together in your solution so that you can maintain them and secure them better, right? And so there's a lot of dynamics that come into play when you're looking at trying to build a cloud native solution. And so when I look at the industry, right, and why is it so hard to do application infrastructure management, it really comes back down to this model that we have today of you have your developer who really just wants to run their code, but there's a bunch of operators in the way and committees of operators that are trying to make sure that we're understanding the business requirements, the business goals, the financial aspects of the solution that we're building, the market opportunities, how we prioritize different solutions. You have another committee of infrastructure operators that are trying to understand what's the dynamic needed within the infrastructure and the platform to support those changes. And then you have, kind of the operator of the operators in charge of looking at how do we provision and manage these different resources, right? And so this is kind of the original operator model that we have in place today. As we kind of look at, how we want to evolve this solution, I think it's important to kind of think about the types of things that need to be addressed, right? So we've heard today about RBAC, about policy, both the definition that we've talked about today, but also how you enforce that. Things like IP addresses, managing containers and VMs, creating like load balancing policies and edge policies and load balancing, creating certificates. Most regulated industries like the one I'm in require MTLS 2.0 requires certificates from hardware encrypted devices, and so you don't just deploy something in a cloud and hope that it's going to be secure, right? We have a lot of compliance and governance controls that we put around our deployments. And so as you kind of think about this, right, you have to kind of look at the processes you're trying to automate, right? So you're looking at your development processes, so your dev actor, you're looking at your infrastructure and platform processes, or your kind of app operators and your platform operators, and you're looking at different deployment practices and change processes that are in place today. And so what we're trying to do is sort of start with the end in mind. And so going back to my previous picture, right, we want to basically automate the provisioning of the operators through operator model, working with Crossplane on sort of our first installation of this. So when the developer says run my code, it's a platform service API that it's hitting. That API has a declarative model that allows it to deploy into different locations and to integrate with different services that are needed to adhere to some of the security and compliance controls that are in our industry. And it has a business API process that kicks off some of the prioritization and financial processes and capacity planning that's needed for the application. So, we kind of think about these challenges that we face today. There's a lot of, scripts, as was mentioned earlier in Kelsey's keynote. There's a lot of pieces of, external APIs that need to be written, and most of these teams do not have, API developers or understand APIs, and so it's a new skill that's needed to be kind of evolved within the enterprise space. We have to kind of build this to run, and so operations and day two aspects of the services need to be thought through, and then decommissioning is always a problem with all the different dependencies that you have on decommissions. And so to kind of give a quick example of the solution, there's basically four components you have to think about. The first is your user experience, and so I want to encourage you to really talk to your users, and I do mean really talk to them. Don't just talk at them. I mean, who are your users, right? Your developers, your app operators, your service owners, your platform operators, and your infrastructure operators. So all of these different operators have different components and models that they're trying to work through and define and support, not just for the easy piece that I think one of the speakers spoke to earlier of creating that API definition, but when something breaks, and it always breaks, when it breaks, you need someone who knows how to fix that problem, especially when every second is millions of transactions, right? Um, you need to create, your YAML specs that are basically define that desired state and make that a standard. Don't allow a lot of abstractions to be built into that standard that allow application teams to request something that's not available and not supported. And then a really big change is having infrastructure and service owners and platform operators that understand how to monitor Git and understand the code changes that come in to that repo and know how to manage those repo changes and approve them quickly. Um, and I think the last but most important thing is obsess over every aspect of that experience. The second thing I want to consider is this definition of done. Too often we try to say there's this end state that we want to accomplish within this period of time, and so we march and create sprints to get to that end state, and then we just keep going. We don't ever say we're done, and so define what definition of done means to you. Expose those APIs, kind of like this new control plane we've been talking about. Make sure that that control plane is a good abstraction of what's needed to sort of deploy everything that's needed to be deployed for that application to be deployed correctly. We kind of mentioned the day two operations piece. So this is a little more specific around define that drift detection, how you're going to monitor for changes, what type of logging and decom are your standards going to be based upon. And then that service assurance and composition that Dan mentioned earlier within Crossplane, right? The composition piece is really important to understand how do you assure that those types of components are being composed correctly and that any kind of change or drift is being detected pretty quickly, especially for your more critical components that you're composing. And then for me, it's like really important to talk about like high availability and security and global distribution, even if you're not deploying your application for that today. It takes you minutes to really define your application to be better deployed in a high available, secure, and global distributed model than if you just focus on building it for a single instance in a single location and then months later have to try to figure out how to make it grow to support global distribution. It takes a lot more time, a lot more effort, a lot more rewriting. You're throwing away a lot of code, that is, being engineering code that's not going to be useful in the future if you don't think about the future up front. The next thing is sort of the implementation plan. And so you really want an API model that is very standards based, but also creates that overarching control plane. The component definitions, Kelsey mentioned earlier, custom resource definitions, these are really important to think about in terms of how do you manage your control plane in a way that lets you really understand these different components that make up that API that you're exposing. When you think about distributed and standardized control plane, think of a plain old telephone system, not cloud. This problem was solved many decades ago with the signaling system 7 protocols and how control was managed across international telephone companies to allow a phone call to be completed. And so don't try to think of it as a new problem. It's a very old problem that's been solved many times, and there are good solutions in place to support this. Think about your controller model as a standard model with separation of concerns designed from the beginning. We've heard this a couple of times today as well, and think about moving towards this GitOps model. And so, in a similar example that Kelsey gave, right, we've also created using some very standard definitions from OpenAPI and Kubernetes, a database service that deploys internally within our environment. It's a very similar definition as you saw from Kelsey for Google Cloud, but this is very specific to just our environment in terms of what the client would request. It also has this idea of components that are very specific to types of components that we would build inside our environment, and the stacks that we would deploy towards and manage the different traits of in the future. In a few minutes, I'll talk about some of the trait components. But again, these are all like very specific, and they're not Kubernetes only services, right? These are designed for both Kubernetes and traditional infrastructure, and they can run and do run today in both. Um, this is, I think, kind of a key point of today, right? Is that you have a lot of on the right hand side, you have a lot of these Chef and Terraform and VMware and Ansible. There's a ton of configuration management and infrastructure automation and infrastructure management tools that are in place. And you don't want your developers or your service owners having to, write specific APIs that only talk to those element managers or those control planes. You want to kind of build a control plane that this IaaS, infrastructure as a service platform that we built in the middle there is going to abstract the underlying implementation from the API that is exposed to the front end that allows a standard consumption of infrastructure no matter where it's being deployed, internal or external. This is sort of, kind of an example of what we've done with, defining our specification, building some controllers that are watching for changes to that implementation, that specification, and if it needs to be made a change, we pass that change off to the external resources to perform those changes. So we built this nice little interface, infrastructure service console. You log in. Based on your login, we collect some metadata that's important to the business and the financial processes I mentioned earlier. And this little initiative number is where we put data and stories to help address some of the security concerns that we show here. And so security is sort of the next tab we have. And as you'd expect at Mastercard, security is by our top priority. And so we put a lot of specific um, controls and policies around how we want security to be handled. We don't, as you can see here, we don't ask the development team to do a whole lot, but to give us information about what the classification is and any data elements, and we've defined those data elements in a nice YAML file that they can pull from. And then from a component configuration, it's really simple, right? We ask them what type of workload they're deploying, what locations they're looking at, and what the traits are. Kind of going back to the Ohm model we've been working with Crossplane on. And this is kind of specific to Mastercard in terms of some of the traits, but again, these are as was mentioned earlier by Alibaba, right? That's really the configuration that's needed for this application to exceed and succeed in this deployment and configuration. So I have an example of the output of this specification. As you can see, it's an OAM spec. We are using some of the Alpha 2 code. Um, we have this running today. Can't give a lot of details about the type of application, but it is being deployed within our environment. It has an example operator here that is, a Terraform module that's is talking to underneath the covers. It's able to talk with the cloud as well. As you can see, it has some Google credentials that we pass through our Vault interface. And so in conclusion, understand the whole problem and the complete solution. Think about that addressing to get to that whole problem solution iteratively, and then keep on iterating. And with that, I'd like to thank you for your time.